This video also continues dispersion for scale variables. Specifically, this video talks about dispersion around the mean, and you should focus on variance and standard deviation. I will go over other methods of finding dispersion around the mean, but you should focus on these two, and the one you should focus on the most is the standard deviation. So you might ask why we have to do n-1 instead of just n for the sample variance. And the answer is degrees of freedom. The degrees of freedom, or DF, for calculating the sample variance is the sample size minus 1. Degrees of freedom are equal to the number of observations minus the number of estimated population parameters that were used in calculating the statistic. For the sample variance, we estimated the population mean, that's a population parameter, with a sample mean. Thus, we have to subtract 1 to get the degrees of freedom. So we had one population parameter, which was the population mean that we estimated. We estimated it with the sample mean. So since we had 1, we have to subtract this 1 from the sample size. Basically, we do this because the sample variance would be an underestimate of the actual population variance without the degrees of freedom correction. The degrees of freedom correction helps fix this and make the sample variance an unbiased statistic. We end up dividing by a smaller number to get the sample variance, thus making the estimation bigger. So basically, you need to know that if we don't have this degrees of freedom correction, the sample variance underestimates the actual population variance. And to correct this, we have to have a degrees of freedom correction. And so we divide by n-1 instead of n. So we end up dividing by a smaller number. And if we divide by a small number at the bottom, then the whole sample variance gets bigger. And so we're correcting for this underestimate. Now I'm going to talk about why the sample variance always underestimates the population variance, and that's why we call it biased. So say we have this population out there, and the values in the population take on numbers from -10 to 10, and each of them are equally likely to happen. So there's a uniform distribution here. I don't have it shown here, but just know that in the population that all these numbers are equally likely to occur. So what happens is the population mean will equal 0 because it's right in the middle and all these are equally likely to occur. So we have this black line that represents the population mean of 0. And say we take a very small sample of 3. And say the first one is -3. The next one that we randomly pick is 1. And then the last one we randomly pick is 5, right? This could happen easily, right? They're all equally likely to occur. And then we're going to find the sample mean for this sample. And so if you add these all up, it'll equal 3, and we'll find that our sample mean is 1. Okay? So -3 plus 1 plus 5 is 3 divided by 3, which is 1. Okay, so there's our sample mean, and you can see it's not exactly our population mean, and that's likely to occur. And if we look at where the dots are in comparison to the two lines, we can see that on average they're closer to the sample mean line, that is the orange color. So -3 is actually closer to the 0, but you can see 1 is actually right on the sample mean line, and 5 is closer to the sample mean line. So on average, they're going to be closer to the sample mean, and if they're closer, that means there's less variability, and variance is a measure of variability. So if they're closer to the sample mean than they are to the population mean, then that means that the sample variance is going to always be biased and always underestimate the population variance. I'm going to review what degrees of freedom are. You don't actually have to know exactly what they are. I'm not going to grill you on this, but I want you to know kind of that they're there and they're there for a reason. And they're not just some random thing that I tell you that you should do. You should kind of know what they are. But if you don't exactly understand it, it's okay. I know it might take a really long time to really understand what they are. So basically, degrees of freedom are the amount of information we are basing our statistic on. In this example, it's the sample variance. But we'll use degrees of freedom in other statistics. When we estimate the population mean with the sample mean, we have less information to base it on. So we subtract 1. So if we're using the population, well, if you're using the sample mean instead of the population mean, we're kind of estimating that population mean. So we have less information. We're less sure, right? We're less sure about our statistic. So we're less sure about the sample variance because we're using the sample mean instead of the population mean. And remember that it always underestimates the population variance when you use the sample variance. So because we're less sure, we're going to subtract 1. So every time we estimate something, we're estimating the sample mean. So every time we estimate a sample mean, we're going to subtract 1 from our n. And later on we'll have more sample means, and so we'll subtract off more than 1. Okay? So the amount that you subtract off is the number of sample means that you have to estimate. And we know that the sample variance is biased and will always be smaller than the population variance, right? You would expect your values to be closer to the sample mean than the population mean. So using degrees of freedom instead of just n helps correct this a little bit. It doesn't correct it all the way, but it does help it a little bit.